Conservation of Mass and Momentum Part 12. Conservation of mass. The essential question is, what is mass? And how do we measure and track mass using systems? Mass, symbolized by a lowercase m, is the total amount of stuff, electrons, protons, neutrons, etc., inside of an object, regardless of its size, shape, etc. In other words, how heavy an object is. Mass also gives us an idea of how much inertia an object has, or how difficult it is to get moving or to stop an object. We typically measure mass in units known as kilograms, but you might be more familiar with pounds or grams. A kilogram is about 2.2 pounds or 1,000 grams. If you want to imagine a kilogram, it's best to imagine a pineapple. For this unit, you're going to need to be able to identify mass within a sentence. Knowing the name, symbol, value, and units for the mass variable is important to be successful. In this example, I purchased a 3-kilogram bag of flour. The name is mass, the symbol is a lowercase m, the value is 3, and the units are kilograms. The next concept we need to explore is the idea of tracking mass using systems. In a closed system, the total amount of mass, or sigma m, will not change no matter how much time has passed or will pass. As you can see, this disorganized pile of Legos from yesterday are now a beautiful pile of structures organized for learning and enjoyment today, but they are still the same matter and therefore the same mass within a closed system. Remember, total mass does not change in a closed system as we are looking at the same matter over time. Things are different in an open system. In an open system, we simply want to look at the object today, and we want to look at how its mass has increased or decreased due to changes. We're going to introduce the term change in mass, which is symbolized by delta M or triangle M. We must also remember something important about mass. Mass is matter, and matter cannot be created or destroyed. It simply moves from one system to another, but it's never removed from existence, even if it's transformed into energy, according to Albert Einstein. But let's transform some matter into something much more yummy. Here is some frozen yogurt. Now, I'm not sure exactly how much mass is in this frozen yogurt, but I do know that I'm going to add 20 grams of gummy bears and 30 grams of hot fudge. Delicious. Now, after I add those in, I take my spoon and I shovel out 230 grams of assorted, sweet, delicious froyo gummy bears and hot fudge and gobble it down. In order to calculate the change in mass, I simply add the gummy bears and the hot fudge, and I subtract how much of the frozen yogurt I gobbled down, and I can calculate my change in mass, which happens to be 20 grams plus 30 grams minus 230 grams for a grand total of negative 180 grams. Now remember, even though this mass has left the system, it was not destroyed. It has simply moved into a new system, which is me. Delicious. So there you have it. We've talked about what mass is and how it's measured. We talked about open systems, and we've talked about closed systems. Please revisit the essential question and answer, how do we measure mass and how do we track it using systems? Thank you very much.